Hello, my name is Paul McDevitt, Applications Engineer here at onsemi. Today we're going to provide you with some basic background knowledge of a stepper motor. We will introduce to you a highly energy efficient stepping motor solution and help you understand where and why you might employ stepping motors and their driver solutions into your design. A motor and its associated driver can be used for many applications in a variety of end markets, including automotive, white goods, home appliances like refrigerator, remote controls, computer peripherals including printers, scanners, thermal management, digital cameras, industrial, medical, game consoles, and audiovisual equipment, among others. Although motor drivers can be used for many different types of applications, there are common challenges that design engineers face when they use motors and their driver ICs in their designs. One of these challenges designers face is power consumption. Most designs today require low power and high efficiency in their motor drive applications and their corresponding motor driver ICs and components. For example, if the board of a fan driver is inside an enclosed case, heat is generated and extra power consumption is required to cool it down. An internal fan circulates cool air inside to reduce heat and manage thermals. Therefore, an engineer would look for a low power loss requirement as well as a powerful and highly efficient cooling function motor. From an end user perspective, reducing noise generated by the motor is highly desired. In addition, a designer must also be able to compensate for any external noise or vibration in the system. One of the general consumer trends, whether due to limited living space or user preference, is the high demand for compact solutions. This trend leads to a preference for a smaller motor size with low noise, which is not always possible when trying to compensate for other design requirements. Since high voltage power is required to drive white goods, industrial applications, etc., durability and safety is important. Not to mention, an engineer needs to choose a reliable motor and driver IC that can control speed accurately. So, how does a stepper motor work? Stepper motors are commonly used for precise control, and techniques like microstepping are used to reduce motor vibration. A stepper motor is operated by pulses and is often referred to as a synchronous motor. A stepper motor controls rotation by switching MOS transistors off and on. When current is flowing through out 1 and out 2, the rotor of a permanent magnet is held as shown. Switching the current through out 1, 2, 3, and 4, the rotor rotation can be controlled. Its rotation angle is in proportion to the number of pulses and its speed to the frequency of the pulses. You can control the rotation precisely by controlling the number of pulses, making this suitable for positioning. Let me show you an example of a stepper motor using a hybrid type. Here is an exposed view of a hybrid motor. The stator housing is laminated to reduce the eddy currents and holds the stator poles with windings. The poles have teeth, 200 in total for one complete revolution, for a 8-degree motor. The rotor has 2 rotor wheels, both with 200 teeth also, but shifted. You can see more in detail in this cross section. In between the rotor wheels, a strong permanent magnet is positioned. In today's discussion, we are going to focus on stepper motors and drivers for office automation applications, including end products like printers and scanners. Typically, a stepper motor would be used in a printer for paper feed because this function requires positioning control. Stepper motor paper moves from point A to point B accurately, as shown in the right-hand side figure. If a silent drive is the end user's priority, a microstepping motor drive is recommended. A stepper motor and DC brushed motor are used to compress the ink ribbon to paper. The thermal printer prints the documents by compressing and heating the paper and ink ribbon. A stepper motor is also required to adjust the pressure of the ink ribbon on the paper where positioning is necessary. In desktop scanners, etc., designers select a motor control for positioning function, low vibration, and a wider range of motor rotor control. Low vibration is required because a vibration makes it difficult for a scanner to read an image or letters precisely. A wider range of motor rotary control is required to reduce the repetition time of scanning and magnification and reduction of a document. The LV8702 from onsemi is a highly energy efficient stepper motor driver IC. The device was specifically designed for office automation equipment applications like copiers, scanners, and multifunction printers. The poor energy efficiency of stepper motors utilized in a wide range of electronics applications has been an area of concern to communities the world over and a challenge to power system design engineers. The LV8702V meets this challenge by providing a unique driving system that enables it to achieve no-load power consumption savings. In this demonstration, you can see some of the many benefits that the LV8702V offers. First, we turn on the motor switch. This switch activates the LV8702V motor driver IC to show its effectiveness. As the motor starts running, we measure the motor current using a waveform. Next, while keeping the motor driving, we turn on the high efficiency switch. As you notice, both motor noise and vibration are decreased as soon as this product feature is activated. You can also see the significant difference in motor current level before and after the high efficiency switch is turned on. The waveform becomes more flat, which indicates lower power consumption. Next, we touch the motor to add load to the motor while it's running. When a load is added, the power consumption increases, and then the device optimizes the current level. Next, we add more load to the motor. The motor eventually becomes out of sync or stepped out. The stepped out detection function is triggered by which the DST1 signal is sent. We also tested the surface temperature of the driver IC. Since our driver IC realizes low power consumption, it reduces heat generation. As you can see in these images, due to the increased efficiency, the surface temperature of the driver IC and the motor are decreased by up to 46 degrees C and 28 degrees C respectively with the efficiency feature activated. This feature has the potential to overcome the need for cooling fans in some applications, along with the corresponding space and cost savings and enhanced system reliability that the IC provides. The LV8702V stepping motor driver IC detects motor condition through driver waveform monitoring. Power consumption is reduced by automatically reducing the current value according to the rotation speed or load of the motor. The device has an operating voltage range of 9 volts to 32 volts, and protection features include output short circuit protection, a thermal shutdown function, and a step-out detection function. This solution greatly assists the design engineers in the development of office automation electronics that meet the global demand for improved energy efficiency. As you can see in this block diagram for office automation equipment, stepper motor drivers and H-bridge drivers are used for a variety of functions in office equipment, including paper feed, crimp, paper lift loading, and scanning, as well as many others. For more details regarding the complete onsemi stepper motor driver portfolio and design solutions, contact your local onsemi sales representative or authorized distribution partner, or visit our website at www.onsemi.com. Thank you.